In this video, we are going to be discussing problem number 6.23 from your exercise questions. And yes, I started using the new textbook, yay me. And the reason I started doing these videos is because I felt like equilibrium is close to being done and I want to start working on this so that we can finish this chapter once and for all. And I've been working on this chapter for about 2 years now. So yeah, so this question at 1127 Kelvin and 1 atmosphere pressure, a gaseous mixture of CO, that is carbon monoxide, and carbon dioxide is in equilibrium with solid carbon at 90.55% carbon monoxide by mass. Calculate the value of Kc. So we need to figure out what the equilibrium constant, right? So let's write down what's been given to us. So the first thing they've given us is the temperature, which is 1127 Kelvin. We have the pressure, which is 1 atmosphere. Okay, and we have the percentage of carbon monoxide by mass is equal to 90.55%. Okay, so we need to find the value of Kc. Now, as we know, we've been given everything that can get us to the value of Kp. So what we are going to do is we are going to try and calculate the value of Kp for this particular equation and use the formula to convert to Kp to Kc. So that's how we'll be doing this particular problem. So first thing we've been given is that 90.55%. So 90.55% by mass of carbon monoxide implies that you have 90.55 grams of carbon monoxide plus 9.45 grams of carbon dioxide. Okay, so this is the case. So 90.55 grams of carbon monoxide and 9.45 grams of carbon dioxide. And this is going to be in 100 grams. Okay, so this is what we have. Now from here, we can calculate the number of moles of carbon monoxide and carbon dioxide. So number of moles of carbon monoxide will be equal to mass by molar mass, right? So 90.55 divided by the mass of carbon monoxide is 28, that is 12 plus 16. So this is going to give us 3.2339 moles. Similarly, we can calculate the number of moles of carbon dioxide. So this will be equal to 9.45 divided by, what's the molar mass? 44 for carbon dioxide. And so this is equal to 0.2147. And this is one of the reasons why your first chapter is so important. It's because all of these concepts are taught in detail for you in the first chapter. So definitely remember to at least do the numericals from your first chapter. It's really important and gives you the basic idea for all your chapters. Like it also helps in class 12. Anyways, so from Dalton's law of partial pressures, we have P1 is equal to X1 into P total. Okay, so we are calculating. So for us to calculate the partial pressure, so essentially what we'll do is we'll have to calculate the partial pressure of these components. We can calculate the value of Kp. So the Kp value can be calculated from the partial pressures of carbon dioxide and carbon monoxide. So for us to calculate the partial pressure, you have P1 equal to X1 into P total. So we obviously need the value of X1, which is the mole fraction. So we'll calculate the mole fraction of carbon monoxide. So XCO is equal to 3.2339 divided by 3.2339 plus 0.2147. See, I told you the first chapter, super important. So this gives us 0.9377. Now you can either do this division again or you if you're like me who prefers to do addition and subtraction, you can just do XCO2, which is a mole fraction of CO2, is going to be 1 minus 0.9377. So this is equal to 0.0623. Okay, so we have the mole fractions of individual components, and we also have been given the pressure, the P total, which is equal to 1 atmosphere. Okay, so we are able to calculate the value of the individual partial pressures. So you have PCO is equal to X1, which is carbon monoxide mole fraction, which is 0.9377 into 1 atmosphere. And mole fraction does not have any units, right? So you have 0.9377 atmosphere. So similarly, P of carbon dioxide is going to be 0.0623 into 1 atmosphere. And this is going to be equal to 0.0623 atmosphere. Okay, so we have been able to calculate the individual partial pressures, right? So Kp will be equal to partial pressure of what? The carbon monoxide, partial pressure of carbon dioxide. So you're going to have PCO square because of the 2 in front of carbon monoxide divided by PCO2. So you just have to substitute the values. So you're going to have 0.9377 square divided by 0.0623. Okay, so this is equal to, so 0.9377 square gives us 0.8792 divided by 0.0623. And this on further simplification is going to give us 14.112. So we finally managed to calculate the value of Kp. Okay, so now the next thing we need to do over here is to calculate the value of Kc. Now we know the relationship between Kp and Kc is that Kp is equal to Kc into RT to the power delta n. Now, n is the difference in the number of moles. So, delta n will be equal to 2. That is, you have 2 CO and then you have 1 CO2. So, it is going to be 2 minus 1, that is equal to 1. So, delta n equals to 1. Temperature was given to us, which is 1127 Kelvin. Okay, so Kp will be, so Kp, we're just going to rearrange this. So you're going to get Kc equals to Kp divided by RT to the power delta n. Now let's substitute all the values. So 14.112 divided by R, which is the gas constant, which is 0.0821 into temperature 1127 to the power 1, because 2 minus 1 equals to 1. So you will get, when you simplify this into this, you get 14.112 divided by 92.576, and this gives us 0.1525. So this is the value of Kc. So essentially what we did in this particular question, for this question, was that we were given these things. We were given the percentage of mass of carbon monoxide. We had to calculate the value of Kc. We have also been given the pressure and the temperature. So we first started by calculating. So the basic idea was that we can calculate the value of Kp from whatever information was given to us. And you have a relationship between Kp and Kc. So we thought that we can do it this way. So basically we started with calculating the number of moles of carbon monoxide and carbon dioxide. Then we calculated the mole fraction. And then we used the Dalton's law of partial pressure to actually calculate the value of the partial pressure of carbon monoxide and carbon dioxide. From the partial pressures of each of these, we were able to calculate the value of Kp, and then we used the equation or the relationship between Kp and Kc to calculate the value of Kc. I hope all of that made sense. In the next video, which I'm hoping I'll post on Tuesday, we are going to be discussing the question number 24.